morning. Today we are going to discuss about simply supported beam. In the simply supported beam, how to calculate the slope and deflection by using the W integration method, right? So this is a simply supported beam. It has a central point load, where it is subjected to downward load. The supports, the deflection will be zero. At the center point, deflection will be maximum. Deflection will be maximum. When deflection is maximum, here the slope will be zero. The slope will be zero. If you draw a horizontal line, if you draw a tangent, it will be horizontal line. Then the slope will be zero. So at the point A and B, deflection is zero. So now the first step is to find the reaction at A and B. So this is point A and this is point B. Since the load is acting at the center, the reaction at A is equal to W by 2 and B also W by 2. Now you take axis XX. You take axis XX here and you write the bending moment equation. So here this is the distance is X from the left support. It is X. So now the bending moment is Mx. We can say Mx is equal to W by 2 into X. Now if you substitute this bending moment in the differential equation for bending, that is EI into d square y by dx square is equal to m. What is m? M is equal to W by 2 into x. So first integrating it, if you integrate it, integrating once, you will get EI into dy by dx is equal to W by 2 x square by 2. Integration for x is x square by 2 plus a constant c1. Integrate again, you will get EI into y is equal to W by 4 into x square, that is integration is x cube by 3 plus c1 into x plus c2. So this is integration. Now apply the boundary condition on this equation. What are all the boundary conditions? First boundary condition is when x is equal to 0, that is this point, A point. When x is equal to 0, the boundary condition 1 is when x is equal to 0, y is equal to 0. When x is equal to L by 2, when x is equal to L by 2, that is center point. At the center point, when x is equal to L by 2, dy by dx is equal to 0. Slope is equal to 0. You first apply this boundary condition. First you apply this boundary condition in this equation. Then EA into what is dy by dx, that is equal to 0. That is equal to W by 2. What is the value of L? L is equal to, the x is equal to L by 2. Then L by 2 the whole square. Here we have another 2. So this will be 4. W by 4. L by 2 the whole square plus C1. Now this is L square. 2 square 4. So 0 is equal to W L square by 16 plus C1. Then C1 is equal to minus W L square by 16. This will be the value of C1. Now you substitute this boundary condition. X is equal to 0, y is equal to 0. Which equation? This equation. This equation. If you substitute this, you will get y is equal to 0. Then 0 is equal to x is equal to 0. So this will be 0. This will be 0 plus this also 0. Because here we have a x plus c2. So then C2 is equal to 0. C2 equal to 0. Now we know have the value of C1 and C2. Then we can write the equations, slope equation and bending moment. If you write the generalist form of slope equation, that is EI into dy by dx is equal to w x square by 4. What is E1? Minus w L square by 16. So this is the slope equation. Similarly, the bending equation is, this is a bending equation here, EI into y is equal to w by 4. So 4 into 3, 12. So w x cube divided by 12 plus here C1 is minus. So minus w L square by 16 into x, already C2 is equal to 0. So these are the two equations. One is slope equation, another one is deflection equation. So by using these two equations, you can find the slope and deflection at any point because it's a function of x. Function of x. If you want to find the slope at where slope will be more, at the point A and B will be subjected to maximum slope. Since it is symmetrical, A and B will be same. So here in point A, what is the slope? If you draw a tangent like this, then this will be the slope. This will be the slope, theta A. So if you want to find slope at A, what is the distance x? X is equal to 0. X is equal to 0. X is equal to 0, substitute in this equation. You can find the slope. That is EI into dy by dx is equal to x is equal to 0. So this term will be 0. 0 minus w L square by 16. So dy by dx is equal to minus w L square by 16. So in this equation, we get minus. What is the meaning for what is the meaning of this minus? If you find the slope, about horizontal, this is clockwise direction. If you take counterclockwise direction, that is positive. We are taking here counterclockwise direction, clockwise direction. Counterclockwise direction is positive. This angle. So here we are taking minus. So minus WL square by 16. So this will be the maximum slope. Will be the equation for maximum slope. Similarly, if you want to find maximum deflection, equation is the maximum deflection will be at x is equal to L by 2. X is equal to L by 2. You substitute in this equation x is equal to L by 2. If you substitute, EI into y is equal to W by 12 into L by 2 the whole cube minus W L square divided by 16 into x. If you find the value, W L cube minus 12 into this is 8. 12 into 8. This is 8 minus W. Here x, you have to substitute the value of x. X is equal to L by 2. L by 2. Then W L cube divided by 16 into 2, 32. So if you find, it will be W L cube divided by 48. If you find the value of y, y is equal to W L cube divided by 48 EA. So this will be the maximum deflection equation. If you want to find slope and deflection at any point, you use these two equations by substituting the value of x. If you want to find the maximum slope, this equation, maximum deflection, this equation. So this is about slope and deflection of simply supported beam subjected to point load. So now you take this problem. In this problem, this is also a simply supported beam, but subjected to uniformly distributed load. So here also the point A and B will be subjected to maximum slope, and the center point will be subjected to maximum deflection. If you find the slope will be 0 at the center. Slope will be 0 at the center. That is L by 2. And deflection will be 0 at point A and B. So the first step here also to find the reaction at A and B. Reaction at A and B. So here the load is W. That is per unit length. So total load will be W into L. W into L. If you find at reaction, the half of the load will be supported at A and half of the load will be supported at B. So the reaction will be W L by 2. Here also W L by 2. So now take axis at this location, and write the find the bending moment and substitute in the deflection equation. Differential equation for deflection. The equation is EI into d square y by dx square is equal to m. Here what is m? M is equal to W L by 2 into x. So this is here left side clockwise moment. Left side clockwise moment. So we are taking plus, that is W L by 2, that is a load, multiplied by distance x, minus this load. For this load, what is the load? Load is equal to W into x. That is a load, W into x, multiplied by it will be acting at the center. So x by 2. X by 2. Wx square by 2. So this is the equation. Now you integrate once. Then the equation is EI into dy by dx is equal to WL by 2 x square by 2 minus here W by 2 we have x square, that is x cube by 3 plus C1, a constant. Again, if you integrate, you will get EA into y is equal to WL by 4. WL by 4 into we have x square, that is x cube by 3 minus we have W by 6 into x cube. So x power 4 by 4 plus C1x plus C2. Now you apply the first boundary condition. First, what is the first boundary condition? When x is equal to L by 2, dy by dx is equal to 0. This is a first boundary condition. That is at center point. At the center point, slope is equal to 0. You substitute in this equation. That is EI into dy by dx equal to 0. 0. That is equal to, here x is WL by 2. WL by 2. And here x is equal to L by 2. So here 1 2 is there. So you make it 4. L by 2 the whole square minus W by 2. Here we have into 3. So W by 6 multiplied by x cube by 3. What is x? L by 2 the whole cube. So now if you manipulate this, WL, this is L square by 4. So W, this is L square. So L cube divided by 4. 2 into 2, 4. 4 into 4, 16. 4 into 4, 16. That is equal to 0. Minus, here we have plus C1. Plus C1. This C1. Here it is L cube. 2 cube is equal to 8. 2 cube is equal to 8. Then the equation is W L cube divided by 6 into 8 plus C1. Now let us take these two on right side. Then C1 is equal to, if you take this side, W L cube divided by 6 into 8 minus WL cube into 16. You can write 2 into 8. 2 into 8. And if you find this, if you take commonly 6 into 8, if you take commonly, what will come? Here it is W L cube minus, here it is 8 3 times, so minus 3 W L cube, that will be 6 into 8. It is okay, let us keep 6 into 8. 6 into 8, here it is minus, this is 3 times, the 2 W L cube, right? So if you cancel this 6 and this 2, you'll get 3. So this will be minus W L cube by 24. So this will be the C1 value. Similarly, if you find the, if you say, apply the another boundary condition, that is the boundary condition is when x is equal to 0 and y is equal to 0. This is another boundary condition. If we substitute in this equation, here 0, y is equal to 0, that's 0. Here x is there, x is equal to 0. So 0 minus, here also we have x, that is equal to 0. C1 also, here we have x, that is also 0. So C2. So from this, C2 is equal to 0. Now, generalized form of a slope and deflection equation. So this is a slope equation, this is a deflection equation. Now you substitute the value of C1 and C2, then the equation will be EI dy by dx is equal to, here W L by 4 x square minus W by 6 x cube plus C1. C1 is minus W L cube by 24. So minus W L cube by 24. So this will be the generalized slope equation. Similarly, deflection equation is EI into y is equal to, this is 4 into 3, 12. So W L by 12 x cube minus 24. So W x power 4 by 24 plus C1 into x. So but C1 is minus, so minus W L cube by 24 x, C2 is equal to 0. So this will be the equation. So here you can find the maximum slope. This equation, by using this equation, we can find slope and deflection at any point by substituting the value of x. If you want to find the maximum slope, you substitute x is equal to 0. Maximum slope, that is, if you substitute x is equal to 0, you will get dy by dx is equal to minus W L cube by 24 EI. This is a maximum slope, that is at point A. But the deflection will be at the center. So you have to substitute x is equal to L by 2. If you substitute L by 2, you will get maximum deflection. That will be 5 by 384 W L power 4 by EI. So we have equation for maximum slope and deflection. So these are all the equation for maximum slope and deflection. So this is the equation for maximum slope. This is the equation for maximum deflection. This is a generalized equation for slope. This is the generalized equation for deflection. So this is the way you have to solve this.